Hi everyone, this is Dhanasekaran, Assistant Professor, Department of Electronics and Communication Engineering, KS Rangasamy College of Technology. In this video, we're going to see about MIMO systems in the subject name of mobile communication and networks. So these are the outlines of today's video. First one is what is MIMO, SISO, how MIMO works, advantages, disadvantages, and application. So what is MIMO? In wireless communication, when the multiple antennas are used in both at the transmitting end as well as the receiving end, the configuration is said to be a multiple input and the multiple output are MIMO. So MIMO helps in sending and receiving multiple data signals simultaneously. MIMO is a smart antenna technology, the other popular technology being multiple input, single output, and the single input and multiple output. So in the electronics engineering, there are two key approaches in the field of control engineering. There are single input and single output and multiple input and multiple output control system, which are essential to design and analyze the dynamic systems. So this is a basic structure of MIMO system, the transmitting side and the receiving side. And the MIMO systems are similar to control system in that they handle scenarios in which the numerous variables can simultaneously affect a wide range of outcomes. In today's network systems, these are essential because of many components need to communicate with each other in industries like robotics, airplanes, and chemical process, where the effective control systems and optimization need the consideration of several factors. These MIMO control systems are extensively used. So next, single input and single output. In the control system, the process that involve only the input and generate the single related output is referred to as single input, single output, or SISO. The main goal of the single input, single output systems is usually modify and control the output in the accordance with the features of input. So there is a clear and direct relationship between the input and output, the structure, simplicity of facilities and focused analysis of systems behavior and makes it easy to apply various control and signal processing techniques. This is a single input and single output structure. In many engineering applications, including automation, communication, the electronics, the primary objective to regulate the optimize a single variable parameter response to a given input. This where the single input output, single input, single output systems were come to into play. Researching and designing SISO system is crucial to understanding and enhancing operation of many tools, procedures in the real world. So we have a digital signal processing with a transmitter, and another side we have a trans receiver, and again a digital signal processing. So coming to the multiple input and multiple output. In control system, multiple input, multiple technology likely to cool upgrade of sending and receiving data instead of using just one antenna in each and it uses bunch of them. It functions similarly to the several LANs on the freeway of flow of data. Multiple antennas are used in MIMO transmission to send multiple streams of data. So while many antennas are used in reception to gather the data, multiple antenna and multiplexing, MIMO for short, in the fancy of name of for the procedure. The primary objective of the are to increase throughput, optimize the utilization, and ensure the optimal system performance. It's similar to supercharging your Wi-Fi. MIMO uses multipath propagation and spatial diversity to address the signal difficulties such as fading, interferences. These are only technical technology ensuring that signals travels distinct routes to their intended location. So it's improving overall wireless system performance. This is a structure of multiple input and multiple output. We have a digital signal processing transceiver, two transistors we have, and the output side we have the two transistor and the digital signal processor. The control strategy of MIMO systems are inherently more complex, requiring consideration between the various inputs and outputs. As compared to a SASO system, designing control techniques for the MIMO system is more difficult since these complex relationships must have taken into an account multiplier transfer functions and state space models are two-way metrics are used to represent MIMO systems. So advantages of MIMO systems. So numerous variables need to be controlled simultaneously, and the better disturbance and shifting operations conditions. In order to achieve optimal system behavior, the control built to take an account relationship between different inputs and outputs. The controller optimizes the system functioning, energy efficiency by taking into account relationship between the variables. So disadvantage, MAM system have more inputs and outputs compared to SASO system. They are naturally more complicated. MIMO system frequently exhibit a high-ended sensitivity to error in the system modeling because even tiny modeling mistakes can have a big effect on control systems. Compared to a SASO system, implementation of MIMO control algorithm might need to be advanced computational resources. So coming to the applications of MIMO system, the system used to simultaneously manage the numerous control surfaces, flight control, chemical facilities use MIMO systems to regulate a variety of parameters and including flow rates, pressure, temperature. So the variables that are altered such as wall position in the inputs and variables that the control are called outputs. So wireless communication system having multiple antennas that transmitter and receiver employ MIMO systems. So robotic systems with numerous actuators, sensor employ MIMO control systems. So in SASO have a temperature and sensor control machines. So MIMO mostly the aircraft control systems. So after watching these videos, go through these questions. Thank you for watching.